Hello, in this example we have a trigonometric equation, and this trigonometric equation also has algebra equation with it as well. So if we look at the structure, it seems like we have a quadratic equation because we have some unknown. The unknown is cosine, that is squared, and then there is more cosine, and it looks sort of like a quadratic equation. In fact, we can make it into quadratic equation by a change of variable. We can say let x be equal to cosine, then we can replace all of the cosines with x, and we would have 2x squared minus 5x plus 3 is 0, which is exactly quadratic equation. And to solve it, we use quadratic formula, which is minus b plus minus square root of b squared minus 4ac, the whole thing divided by 2 times a. So for us, the coefficients are the a is 2, the b is minus 5, the c is 3. So we would get minus negative 5 plus minus square root of negative 5 squared, and then minus 4 times a, which is 2, times c, which is 3, divided by 2 times a, which is 2. So we have two negatives, minus and minus make a plus, so we have plus 5 plus minus square root of negative 5 squared, that's 25. 4 times 2 is 8, 8 times 3 is 24, and then 2 by 2 is 4. So 25 minus 24 happens to be 1, and so we have 5 plus minus square root of 1 is also 1, divided by 4. So we have two answers. 5 plus 1, that's a 6 over 4, which can be reduced to 3 halves. And the second solution is 5 minus 4, which is 4, divided by 4, which is 1. So we have two possible choices, 3 halves and 1. So what that means is our variable x is either 3 halves or the x is 1. But we didn't have the x to begin with, so we have to go back to the original variable, which is cosine. So that means either cosine theta is 3 halves or the cosine theta is 1. Well, in order for the cosine theta be 3 halves, the radius has to be more than 1. We are on the unit circle, and 3 halves makes 1.5. So this question says, if I am on a unit circle, here is my circle, the vertical is the sine, horizontal is the cosine, what angle do I have to rotate so that this length turns out to be 1.5, which is here, 1.5. Because the radius on a unit circle is at most 1, we will never get to be 1.5. So this question has no solution. That's not possible. But can the cosine be equal to 1? Yes, that is possible. If we're at this point, that's exactly the length of 1, which happens to be at 0 degrees. So if theta is 0 degrees, then that would work. And any other multiple of 360, so if we go around the circle multiple times, then we would get to the same exact location as many times as we want. So if we have theta is 0 plus 2k pi, and the k is just a natural number. So k is an element of natural numbers. So k is either 0 or 1 or 2. Well, actually 0 doesn't work, but if we put in 0, we get back our original equation, 0, our original answer 0. But the answer is 1, 2, 3, 4, and so on. So for any of these rotations, any of these numbers, we will get just extra rotation around the circle. So we would simply be at the same position after 1 turn, 2 turns, 3 turns, 4 turns, and that's what these numbers say. So if our answer is not restricted to 1 rotation around the circle, then we just add 2k pi to the answer to show that if we go around the circle once, we'll get, or multiple times, we'll get to the same point, and that same point will work again and again and again. And that's it for this video. If you have any questions on anything, please let me know. One more thing that we can also do is we can check the answer with the calculator. So before we close, let's do that also. So here's the calculator, and if we type in this equation just the way it is, our picture should confirm or disprove our answer. So let's put in 2. Now cosine is squared, and so it may be easier to type in cosine in parentheses and then close the parentheses and then square. Now minus 5 cosine x plus 3. And now we're looking for the places where this graph crosses our x-axis, which is equal to 0. So that's the negative side. Here's our answer, 0. And there is one more answer here. But what is this answer? This answer is exactly the same as this answer, because if we look for it, it will be 360, which means we're back at the same point. So this point is 0 degrees, and this point, let's find what that is. So we'll get closer to it. Here, first curve. Well, actually, I've selected the wrong choice. I should not be looking for the intersection. I should be looking for the 0. So we'll go back to the calculate, look for the 0, and left side, yes. Right side, let's move to the right side. Yes, yes, yes. And the answer is 0 at 359.99 degrees, which is a round-off error of 360. So this point is 360 degrees, this point is 0. It's exactly the same point on the unit circle. That's why it works. So that's exactly what our answer shows. It's 0 plus any multiple of 360 at the same location. And that's exactly our answer. So that's it for this video. If you have any questions on anything, please let me know. Thanks for your time. Take care.